Today I'm going to run through, in a very fast manner, an overview of the 2014 fire season. You're looking now at the cover from last year's report. This year's report isn't quite done, but should be out soon, and takes a similar approach and covers similar topics. So this year we looked at the 12 largest fires in the Southwest region. You can see them all on the map. Most of them were in Arizona, but a couple in New Mexico as well. And one of the notable aspects of the 2014 fire season was not all that many acres burned, particularly when we look just at the number of wildfire acres. The only year in recent times that's similar is 2007, but it's particularly in comparison with the last few years, there's a notable decrease in the number of acres burned. And we'll talk more about that because I think there's some other changes in comparison to recent years with respect to severity. So the data we use for this report, or that I use for this report, comes from publicly available data sets, and that's part of the point, is to show what can be done with these publicly available data sets like land fire, and also to have a format that's replicable by anybody else if they want to go in and do the same kind of analysis that I did. One of the data sets I used was the wildland urban interface. And I include this not because it's a perfect map, but rather because it's great to have a view of where fires interact with homes and urban environments, or at least the WUI. Other key pieces of information come from the Remote Sensing Applications Center. They create the soil burn severity data, and this is often used in BEAR projects. And really looks at the effects of fire on the soil resource. A similar remote sensing data source is the RAVAGE, or Rapid Assessment of Vegetation Condition After Wildfire. And the RAVAGE data essentially uses the same information as the soil burn severity data, but looks at a slightly different ratio of change, and based on some past research, tries to hone in on the overstory kill, essentially, the death of the overstory due to fire, and then tries to label the amount that the overstory was killed, so the canopy mortality, essentially. And so you'll see those maps throughout this presentation. I use past fire data that's archived by the USGS to look at past burn perimeters. I use data from InciWeb. InciWeb, during the fire season, as you all know, provides information about what's going on with the fire, about some of the management approaches, provides some images, and is a great source while the fire is happening. But after the fire, the information can kind of disappear from InciWeb so they can make room for the next year's fire information. So I try to archive this while it's available and include it in the report. I also use data from the Southwest Coordination Center, and they record the number of fires, their size, and some other attributes for each year. And this allows me to look beyond just the largest fires, but also look at some of the statistics for fires that are greater than 100 acres. So throughout the report, I talk about sort of the overall fire season, or the overall number of acres burned, using some of the Southwest Coordination Center's data and the way they label fires. This is an example. For each of these, obviously, on this side are the wildland fires, and then they record things. They label them as a suppression fire, or a monitor, or a point protection. They also label the cause as lightning or human caused, and the acreage. So this is a nice data source for all fires greater than 100 acres. So diving right in, there are a lot of fires to cover, and I'm going to kind of zoom through them, but The first, and this is in order of size, the first and largest fire is the skunk fire. It's about 74,000 acres. It was lightning ignited on the San Carlos Apache Nation. And this photo is probably fairly typical of the way the skunk fire burned. As the map shows, much of it burned in a low severity or unburned, basically no soil effect. So when we look at the soil burn severity map, although there are a few spots of high severity on the map, when we look at the percentages, it's such a small area that it's overwhelmed by the other 74,000 acres in the fire. And another important point is that the skunk fire is in a matrix of other older fires, the Bear Canyon, the Creek, the Lost Springs, the Shorten, etc. And there are a few others actually in 2014, the Spring and the Barlow, and the Basin, which we'll talk about in a moment. But I guess it's important to recognize that the skunk was not an anomaly, but rather part of a matrix of fires along this rim in the San Carlos Nation. So the Basin fire was a much smaller fire adjacent to the skunk fire, only about 6,000 acres, also lightning ignited, and similarly the vast majority of it had very low impacts on soil resources. So the summation of the skunk, I think, based on some information coming out of the San Carlos Apache Nation, is that it had beneficial effects across most of its acreage for the forest and the fire-adapted ecosystems through which it burned. A very different fire, the Slide fire, was human-ignited, and it burned about 21,000 acres. And the Slide fire was actually one of the recipients of the Incident of the Year awards from the Southwest Fire Science Consortium. And if you want to learn more about why it received this award and the managers who worked on this fire, why they received the award, please do look at the Southwest Fire Science Consortium webpage. But the quick and dirty story is that the managers were able to bring beneficial fire to more acres, even though it was difficult circumstances to work in. And I think this map kind of highlights some of those difficulties. And when the Slide fire started down in this canyon, you can see there's some fairly large high severity patches, and obviously there's some homes and WUI environments down there, and so that was a very difficult environment in which to work, and suppression was obviously a key focus. Then later, as you look at some of the reports, the Incident Command's 209 forms, it talks about the objectives or the strategies for that day. You can see that the strategies changed, and they drew a fairly large area, that's I guess sort of wrong, a fairly large area in which they were wanted to see natural fire sort of return to the ecosystem. And so much of the area on top of the plateau burned at very low severity and likely benefited the forest and the fire-adapted ecosystems in that area. So this is a good example where different strategies were employed at different times and different locations in one single fire. So although fire managers were very much focused on protecting lives and property during some portions of the fire, during other portions of the fire they could concentrate on helping see that beneficial fire was returned to the landscape. So there's a mix of objectives, although because it was human-caused, the focus was on protecting lives and property. Similar in the Acai fire, about 15,000 acres in the Navajo Nation and was human-ignited. We don't have a severity map, either soil burn severity or the ravage maps for this fire, but we do know that it burned through pinon, juniper, and ponderosa pine forest, and it burned sort of up to and around the East Sand Springs fire of 2012. It did cause some evacuations and burned some structures and affected some human communities as well. The Oak Fire was a lightning-ignited fire that burned about 13,000 acres. And I think, again, this photo is fairly representative, and it shows a sort of mosaic pattern where the fire burned and caused some mortality in other areas where the trees seem relatively unfazed by the fire. And this is borne out by the soil burn severity map, where we can see a few patches of higher severity in a matrix of low soil burn severity effects, and only 2% of the overall fire was in that high burn severity category. When we look at the ravage map, the picture is somewhat different, and this is a good example of how these two maps, or how these two mapping programs differ. In the canopy mortality, we see more areas where 90 to 100% of the canopy was killed during the fire. And just to flip back and forth a little bit, one of the differences between these two maps is what they're attempting to measure. And obviously both have some errors in them just because they're remote sensing data. And so any true picture of what actually the burn severity was would have to be done on the ground. But as a best approximation at this point, when we look at these two maps, we see some differences. And one reason for these differences is the kind of environment that the Oak Fire burned through. It burned through woodland areas with juniper and oak, some grassland areas, some chaparral, ecosystems where it's easier to imagine a canopy being completely killed in a fairly fast-moving fire without detrimental effects to the soil, unlike, say, a ponderosa pine forest where fire sufficient to kill 80 to 90% or 90 to 100% of the canopy would cause significant soil damage that may not be true in every ecosystem. And so I think that's one of the reasons we're seeing some differences in these maps. The Sitgraves fire, jumping on here, was about 11,000 acre fire that was lightning ignited. And again, trying to choose a representative photo, in most areas the Sitgraves fire burned at relatively low severity. And you can see from the ravage map, although there's some striations due to problems with the original remote sensing data source, the Sitgraves fire burned in large majority without killing much of the canopy. So only about 1% of the fire burned at high enough severity to kill 90 to 100% of the canopy. The Hammer fire burned about 9,000 acres, and again was lightning ignited. And you can see the Hammer was managed for a large portion of the operational periods with the McRae as part of the McRae complex. And it was in a matrix of past burn perimeters. You can see some recent ones such as the Skinner and the Hathaway, the Bushy fire from 2013 as well, but then also older fires such as the North and the Camp 36 or the West, where the Hammer burned that same area again. And both the Hammer and the McRae burned in ponderosa pine on the edge of some pinyon and juniper woodlands with some other smaller forest types mixed in. The McRae burned about 5,500 acres, was also lightning ignited, and we do have a ravage map for McRae, and we can see that only about 3% burned with essentially complete canopy mortality. So there are some small patches, but I think these are offset by large areas, over up towards 80%, that burned with less than 25% canopy mortality. We don't have this map for the Hammer, but I expect that the pattern was somewhat similar. The San Juan fire burned about 7,000 acres and was human ignited. And we can see some notable features of this fire were a large patch of high severity where greater than 90% of the trees were killed, essentially complete canopy mortality. This occurred over 25% of the area and also in fairly large patches. So this is a very different picture and the sort of picture that concerns me personally as a forester, thinking about regeneration and how we might see ponderosa pine regenerate into some of these larger areas. The Galahad fire, again, we're flipping back to a lightning-ignited fire that covered about 6,000 acres. And this was on the Grand Canyon National Park and burned through perimeters of past fires, notably the Point Fire, and burned up to the perimeter of the Roost Fire, and burned through portions of the Walla Valley Fire. We don't have at the time I made did this analysis, I didn't have the soil burn severity maps, but we can see that much of the vegetation it burned through was in the low, vegetation that had departed little from historic condition. So this is a measure used in land fire to try to understand how different vegetation on the ground is today than its historic range of variability. So those areas that are highly departed from the historic range of variability might burn in ways that are less characteristic for the forest type. The Signal Fire burned about 5,500 acres and was human ignited. It, like some previous fires we've looked at, had a large area of high severity, almost essentially complete canopy mortality. They covered approximately a quarter of the fire, and I believe that all happened during the first operational period of the fire. So a big run on the first day, causing some pretty severe impacts to the forest resource. And it burned up to and a little bit into the Skates Fire. So again, we're seeing this overlap of fire perimeters as more fires burn through the Southwest. The Pinot Fire is the second recipient of the Incident of the Year Award from the Southwest Fire Science Consortium. And again, this is an award that kind of recognizes the manager's ability to see fire back in its natural role. And the Pinot Fire burned near the Las Conchas burn perimeter, but very different burn severity impacts than the Las Conchas Fire, with only a small percentage, about 6%, burning with high soil burn severity impacts, and mostly in a low or unburned category. So that's a quick view of all these fires, and I wanted to provide a couple of summary graphics that share an overview of these fires that account for, I believe, about 3/4 of the total burned area for the year 2014. And one of the things we see here is when we look at the vegetation types, most of the acreage burned in 2014 was ponderosa pine or pinon juniper. The other interesting thing to note here is that these areas of orange that are the skunk fire drive a lot of the summary statistics. So the largest fires really sort of determine which forest types are most impacted, although ponderosa pine, even though the skunk fire only burned this relatively small area in ponderosa pine, other fires made up for and increased the total acreage in ponderosa pine. Another statistic that we could look at across all fires was the vegetation condition class. And again, because the skunk fire burned majority in moderate or low departure from historic condition, that's the majority of the acres burned across the whole year. But other fires added to those totals. And I don't have any way of backing this up, but my personal view looking at these individual fires is this is likely related to the low severity that we saw across many of the fires in 2014. So where fires are burning through vegetation that is little departed from historic range of variability, ponderosa pine or even dry mixed conifer, these are forest types that when they're in their historic range of variability, burn with low severity, and those are the sorts of severities we saw this year. So there is, I believe, some connection there, although, again, I can't prove that with the data to date. When we look at those fires for which we have ravage data, we see that there's a large portion of the overall acreage in these very low canopy mortality classes, and relatively few acres, about 7,000 acres, in this near complete canopy mortality class. So that's good. I mean, in general, if you're like forests, it's nice to see that we have fewer acres than we've had in some recent years in a high canopy mortality class. Soil is essentially the same picture, relatively few acres here in the high burn severity, soil burn severity class, with most acres falling in low, medium, or low, moderate, or unburned classes. Now, the last set of information I wanted to show relates to cost, and we pulled the cost from the ICS 209 files that are submitted with fires. And in general, we see some connection between as they get larger, they cost more, although that correlation is fairly loose, and we see things like the skunk fire burning a lot of acres and not costing nearly as much, and other fires like the signal fire burning not all that many acres but costing substantial dollars. And I think often this is related to proximity to WUI, but another thing there it's related to is the ignition source. So we see those fires that were human ignited tend to cost more. And I'll leave it to fire managers to explain some of the details of that, but for the layman, I think the take-home may be that where we have lightning ignitions and they fit into fire management plans, they can be managed in ways that require fewer resources than a human-ignited fire that can't fit into a fire management plan, and so require more resources to protect lives and property. So that's, I think, an important split. And in years where we see fewer human ignitions, we're going to see reduced cost overall. Another way to look at this is just looking at the cost per acre of these different fires, and we see things like the signal fire here at nearly $1,500 an acre versus something like the skunk fire or the basin fire at $27 or $3 an acre. So very minimal cost. Hammer fire is a very low cost compared to if we look at those fires that are human-caused. They're all much more expensive than the fires that were lightning ignited. So I think with that, I've come to the end, and maybe I'll end on this slide, and we'll turn it over to Chuck Maxwell to talk about what we think about, or what he sees for this coming fire year, and whether we can expect a year where more fires burn in this sort of low severity environment, or it's one of those quote-unquote bad fire years where we have more fires burning at higher severity. So with that, I'll close, and thank you very much.
Going in this fourth one here, which is the actual pattern that we're seeing during the spring and early summer time frame, during kind of our early and peak fire season right now, and then basically the onset of the monsoon. So looking at these 5 factors together provided a pretty decent perspective on overall general fire potential for large fires across the Southwest, and it's done pretty well. So we'll start with the first factor here. Let's see if my little thing works. Oh, it does. Perfect. All right, so basically we're looking at drought as factor number one. And what we have there in the upper left is the current, or the, not quite current, but it's at least relevant drought monitor, and then below that is the seasonal drought outlook. And what we're seeing on the good side of things is that the conditions that are in California in terms of the drought monitor, those dark red colors, which are severe, exceptional drought, has shifted from where they were over the Southwest 5 years ago, has shifted both west and east of the Southwest area. So our drought conditions have been mitigated just down to moderate to severe. So again, drought is still in the picture. It probably will be for a long time to come. It's not as bad as it has been. And if you look at the outlook here, you can see part of that, and part of that's being experienced now in recent weeks. We've seen some decent moisture and are projected to continue to see drought mitigation, at least probably along and east of the Continental Divide, if not even a bit further west than that, with still drier conditions across Arizona. So basically, the drought conditions we're seeing out there probably are going to stay somewhat similar through most of the season, maybe worsen somewhat a bit across Arizona. But we're not looking at the kind of drought we had before, not quite as bad, not quite a participant in the overall fire picture. However, I got to say, as everybody knows, the nature of precipitation we get out there, and if you look at some of the little sucker holes here on the drought map, there are places out there where we know that it's a lot drier and drought conditions still exist, in areas. And so monitoring may be an important factor for if you're doing fuels monitoring as opposed to using just the raw stations and other factors. May be critical to picking up where drought is still a picture in the fuels environment out there. So other than that, though, drought not as bad as it has been in recent years, and just need to pay attention to it. We'll take a look here at the fine fuels condition. This is quite a story because it's always a big continuum when we're living in here, right? Fire season and fuels and everything runs together year to year. So we start with the last year's monsoon. And if we start with last year, what we can see here, if you look through each one of these months kind of individually, that at least every single one of these areas, or at least one part of the area, saw that bright blue color at one time or another almost every place. So we had areas, or at least a month-long period through the monsoon, that had much above normal rainfall. So that caused pretty decent fine fuels growth during last season's monsoon, warm season grasses, and brought us into this season through the winter with already kind of a normal to above normal loading of fine fuels and grasses and such. So that's kind of the setup coming into this season. Just some examples of the fine fuels, and I apologize, I don't have any from the western portion of the region, but if you look at the little, again, the little bullseyes here from where this comes from, you can see this area here got hit pretty hard a couple times with those green and blue colors. And I wish I had normal pictures down here to show you what it normally looks like down in southeast New Mexico. But it doesn't normally look like that. You would normally see a lot more rock and so forth. That's a fine fuel bed that if the weather conditions and other conditions were ripe, would accept fire and spread it rapidly. And that's pretty consistent with the fine fuels growth that we've seen across the region. And so we're looking at a situation where the whole area is susceptible, has fine fuels which are susceptible to ignition and fire spread. And you know what? No, we don't always have that in some years. In some of the big drought years we've had, we did not have anything of this. We did not have fires at all in the rangelands because there was not any grass to spread fire. Moving on to take a look at the wintertime temperature and precipitation conditions. So what we'll have here will be a temperature map. I'll show you a couple of maps in a row. There'll be temperature on top and precip on the lower left, and I think in all cases here the warmer colors indicate conditions which drive fire. It's either warmer or drier conditions. So I guess if I'm looking at the overwinter conditions, I'm seeing a couple factors here. One is I'm seeing that it's distinctly way more. It's not that much warmer than normal, but it's distinctly warmer across the western half of the geographic area than it is across the east. The eastern plains area of New Mexico and West Texas were below normal for the entire winter. I also see some interesting things when I look at the precipitation anomalies. Still see some sucker holes in there, the red colors. I'm seeing lots of the greens and blues, which mean that we had decent rainfall, or snowfall as it were, through the wintertime. Another interesting thing, speaking to that, what I just said, is rain versus snow. If you look at the snowpack we had coming out of winter, early spring, as of March 1st, despite having pretty decent amounts of precipitation, our snowpack was terrible. We think we might have peaked at near 90% of the normal for a week or two up in the far north central mountains of New Mexico. But the warmer than normal conditions led to there being less snowpack. We still had some snowfall, but it melted pretty quickly. We just didn't really have the snowpack that we'd like to see occur and hold through the entire winter to kind of suppress fire activity and add to my skiing pleasure as well. So we'll go to the next one. That's a big question I get every year, by the way. It's not just about fire. People want to know where to get the ski passes. So again, we'll look at the early, this is March. I apologize, I don't have April, but it'll probably be quite similar. The trend basically from the winter hasn't really changed so much. We've seen, again, not real exceptional deviations from normal, a little bit warmer across the west and the east, but that's basically the same trend. Warmer west, cooler than normal east. Look at precipitation, I'm still seeing variability, which I like. As long as I'm still seeing some of those green and blue blobs on the map through the spring months, that makes me happy. We've had many, many years when that deep red color you see over Nevada and California have taken up residence here for 3 or 4 months on end. So glad to see some above normal precipitation. Also interesting, if you look at where that's occurring there via the colors, those are some of the lowland areas that can grow grass and fine fuels. So kind of hitting some of those same areas again and rebolstering fine fuels growth and green up through the spring. Again, taking a look over here at the snowpack map in the lower right as of April 1st, and this should be peak snowpack across the entire Southwest about April 1st. You want to be seeing the green dots on there for 100% normal, and you can see it was paltry. So Arizona fared very poorly, much below 25% of average for the most part. Portions into Mexico, again, the far north had maybe as much as 75% of normal, but again, not a good snow year. Decent precipitation year, decent precipitation winter, but not a great snowpack winter. And curious to see how they'll play out with the climate change scenarios going forward. Okay, and now we'll do a little bit of the projection part. And again, I apologize because we're already halfway through the projection period. But a little bit about our methodology and why I don't have the updated product yet. We look at a lot of different things. We're basically trying to figure out what the global circulation is, the jet stream, and the hemispheric patterns. Once you can figure out the jet stream and the way storms track and how they strengthen and weaken, those trends change, like they take months to change. So if you can ascertain those ahead of time and be reasonably accurate, you can actually come up with some decent ideas of what's going to happen, not just in terms of whether it rains or snows or whatever, but storm tracks and actual impacts in terms of lightning and winds, believe it or not. So one of the things that we came up with is we did our analysis and came up with some years as analogs to this year. And they indicated basically what you see over here on the far left-hand side, kind of like before, temperatures on top, precipitation's on bottom. That dashed red line is kind of the mean jet stream that we'd anticipated, with maybe a little secondary one coming out of the Baja. And what you're seeing there in terms of temperatures was a trend for cooler than normal temperatures, or at least normal to cooler for the April-May time period. And a precipitation signal with kind of mixed, but basically a good chunk of the area showing above normal precipitation tendencies through April and May, which is huge. That's when our fire season normally starts. If it's cool and moist going into the start of the fire season, you obviously delay the fire season, plus we're growing more of those fine fuels the entire time. It's also great to see when our methodology matches up with that of the official prediction center, the Climate Prediction Center for April and May, and it does. They are keeping the warmth and dryness hugging the west coast and bringing increasingly cool and moist weather westward into the southwest geographic area. Not so bad. Could be worse. So again, when we're looking at the big picture pattern, one of the real critical things we talk about is, again, this jet stream, the hemispheric circulation, and so forth. And when does that change? Because that ties into the monsoon, it ties into wind events, ties into whether we get lightning, more lightning versus more wind. And again, what we're really just kind of doing here is validating what we saw before. This is the big picture, jet stream kind of perspective that shows it, dipping in across the southwest, basically dipping across the whole southern southwest tier of the country. But if you look over towards the June time frame, this is the prediction for as we move towards the monsoon, that jet stream eventually is going to shift northward. And we're going to build a big high over the southwest, and it gets hot and dry for a period of weeks, maybe a month or more, and that's typically our peak fire season. So what we can get from this with the current pattern we're in is we know we're not going to see a lot of windy and dry events right now. We're not going to see like a 2011 where we had gravel blowing winds and we have 3 or 4 red flag days per week. We're not seeing that. We're seeing much more in the way of moisture and lightning, convection. And that trend will probably carry into the start of June before it dries out, which means we're going to have a lot of lightning-ignited fires out there. And the lightning ignitions we'll probably have more of them this season overall than we have probably in some recent ones. And that may be one of our ignition problems along with the human, which is always a factor. So again, the key here is we move into June and we have all those fine fuels out there and it gets hot and dry and we're getting a similar pattern. We're going to see a lot more starts with fires that move. Moving to our last general factor here, the monsoon. I think we've kind of, it's not going to say we've given up yet, but we're on the verge of it. Monsoon prediction is not a good business to be in, but monsoon analysis is a much better business because it's already after it's already occurred. So what we already know is that the monsoon tends to kick in across this area. It takes about 6 weeks from east to west, and these are the median times when we stop seeing large fires. And for most of the areas, it's sometime from early July, the first week in July to the third week in July. And really, through all the years we've tried to make predictions of this and onsets, it really hasn't varied by much more than a week or two. So we really don't feel we need to go to mess with the time too much. It just seems like the monsoon appears like it will be on time. In fact, we may roll right into a monsoon without stopping. And we don't really see any issues with winding the season down on time. That's really the biggest issue. Will our season end on time? And definitively so that resources can shift elsewhere, so we can change strategies on some of the fires and so forth. And yes, that does look to be the case. I will point out this one bullet in the bottom here. We are seeing some conflicting signals later in the summer. We're talking about a potential El Nino onset, maybe even strengthening through the summer, which is kind of weird. That can lead to some strange monsoon patterns later in the year. We do see a possibility that the eastern half of the geographic area, parts of New Mexico and West Texas, may become drier later in July and August, and it usually isn't too bad, but depending how dry it gets and with all the fine fuels out there, that's something we're going to have to watch. It will not take much with the amount of fine fuels we have. If we see cloudless days, we will have fires eventually. So long-term concern, short-term, monsoon on time. And really what I'm doing here is providing kind of just a textual rundown of all the different stuff I just showed you. Basically drought condition. I think I'm going to skip to the next one because I like the next one better. But basically, if you go online to our website, you can look at the same exact thing and read each one of these bullets, just basically pointing out the same exact conditions I did. But I think I have a better way to show you in the next slide, so I'll shoot with that. Okay, well, it doesn't exactly work like I thought it might, but one of the things I've done here is not counting the monsoon feature, looking at the first 4 factors, see how they align. We like to talk about alignment in fire, alignment of conditions. Drought, the fine fuels, the seasonal temperature precipitation, and the weather patterns. Which of those might be conducive to large fire problems, quote unquote. And I kind of assessed and analyzed that and overlaid them, and the colors match the layers you can't see really well. But where you can see is where they all overlap, right? They're not overlapping in eastern New Mexico, West Texas. They're overlapping somewhere over here in the western portion of the area. Combination of residual drought impacts, plenty of fine fuels that are still growing. We had a wet winter, but one that was warm with poor snowpack. And the only thing that's really saving us now entirely is the spring and early summer weather pattern, which has not really been as bad as we thought it might be and may in fact never be quite so bad. We thought there'd be some periods in here we'd see hotter, drier conditions, windier conditions. That still may occur by the end of the month in June, but boy, right now we're not seeing them. So the key, though, is that the focus for any kind of problems this year in terms of large fire potential are across the western portion of the geographic area, primarily, exclusively actually, in Arizona. So another way to look at the same thing is just to tally up each of these first 4 factors. And all I did was basically just add them up, how many out of 4 added up per our perspective, and kind of color-coded it. And you can kind of see an area here that stands out. Folks in Arizona sometimes call this the brush belt beneath the Mogollon Rim, where the grass transitions up into the brush and the ponderosa pine eventually. And areas surrounding that with a secondary, amount of concern, and then from there it goes down rapidly as you head eastward. So right away, this area of alignment here of all these different conditions is key. Now, what's interesting about these is we don't necessarily talk about the timing of the alignment. All these have to align at the same exact time. And if we can't get the spring and early summer weather pattern to cooperate with us like we are right now, the rest of them aren't going to matter. And we'll talk about that a bit more here to wrap this up. But right now, as I think you might know, we're being dominated by the spring, early summer weather pattern is entirely controlling our fire season right now. So I think this is I have one or two more slides after this. The big picture, and again, this is even as a month ago. All of the factors we saw in terms of looking at the whole Southwest, Arizona, New Mexico, West Texas, was looking at a delayed fire season onset area-wide with normal to below normal conditions east, but above normal conditions potentially emerging further west in Arizona as we got warm and dry at some point in June, maybe early July. And all the rest of that stuff basically says the same thing. What it comes down to really is this last one here, is the fine fuels availability. I guess I'll add another one there, plus the drought impacts, plus the spring weather pattern, plus lightning is probably what's going to have a lot to do with our season this year. The fine fuels are very available. Well, they will be once they cure out. There's plenty of them. The drought impacts are there as they are. We've already had lightning. All we need at this point is for the weather to cooperate with kind of normal fire season conditions. Those fine fuels will cure out, and we'll have a situation where we'll be able to start and carry fire impressively across the area that we highlighted. And that's really what's driving things right now. Again, I think I might have mentioned earlier with the pattern we're looking at, we're not looking for a big red flag type year in terms of windy, dry conditions at all. Not seeing many of them, don't expect to. Looking for a lot more in terms of lightning potential day, dry lightning and or just lightning starts in general. So that's something to take with you. So the final picture here, and again, this was updated a while ago. We may be changing this. Over here across the eastern half of the area, we're going to leave it below normal. That's the first time we've gone below normal there in a long time. But based on what we've seen with the recent weather patterns, we may actually be shifting this further westward towards the Arizona border. This area out here in Arizona, this is interesting because I briefed the governor a week or two ago, and we'll see if he still believes me after this. We were kind of counting on this coming in basically at some point in June into early July, counting on this pattern changing, the jet stream shifting north, going into a hot, dry pattern at least for a couple of weeks, and basically bringing things to life in that fuels regime, much as it did in 2005 when we had our season really didn't start till after Memorial Day, but we had some impressive fire activity over here beneath the Mud Gun Rim in Arizona, a couple of multi-100,000-acre fires over in this vicinity, Cave Creek and so forth. That's something like we might see this year. I had some bullets in here about the potential for the fire to move up in elevation into the ponderosa pine mixed conifer forest up there. That's seeming less and less likely given the weather pattern we're seeing. But this is the general trend. If there are going to be any changes to this going forward, it might be to shrink this back down or to focus it more later in the year and to push this below normal area further westward in the geographic area. Well, hopefully it's not mid-May yet, or I'd be breaking my promise here. But that is it for my perspective on the general large fire season outlook here for the Southwest. Do we have any questions or discussion in general, I guess? Zander?
Yeah, and feel free to type in questions, and in a second I'll unmute the phone line. So if you're just on the phone, you can speak up in a second and ask your question that way. But if you've got a lot of background noise, please go ahead and mute your line on your end. So Chuck, I want to thank you. It's really nice to get that walkthrough. I know that some of these materials are available online, but it's a real treat to have you walk us through it. So let's see. Are there questions? I'm not sure we have any questions in the chat window yet. Let me try unmuting the line here. So feel free to speak up and ask questions if you have them.
Well, this is Pepe. I had a question. Like you mentioned that 2005 year. Do you remember when those Cave Creek fires started? Did they started like in June or July?
Good question. Let me pop that up real quick on the old website, and I'll answer your question. Can somebody else cue one up while I find the answer to that one? Stand by.
Looks like it started June 21st.
June 20th, so pretty late, huh?
Yeah, it was late, and I remember looking earlier. I don't remember seeing a lot of even 209 type fires until after Memorial Day. It was just not. It was a slow start, but man, it raged when it did.
Yeah, so I saw another year that was like your anomaly year was 2003. So that was a pretty low year in terms of the fire acres, right, Zander, from your presentation?
Let's switch over there and jump to that. graph. Yeah, so 2003, yeah, was a fairly light year in terms of wildfire acres burned.
Yeah.
Probably, yeah, 2003, 2007, 2014 were low years.
Okay.
I remember that 2003 included the Aspen fire that impacted Summerhaven.
Oh, that's right, huh?
And,
yeah,
and
so
we had
in Arizona looking.
Yeah, we had one of the hottest Julys on record in Albuquerque with 103 consecutive days in mid-July. It will stay. Yeah, I mean, a lot of these things too. You're looking at the time from cure out till monsoon start. Sometimes that's 6 weeks or 6 days, and that's a lot to do with this. Yeah.
Chuck, in your 5 factors for predictions, are energy release components considered in any of those?
Not specifically, but the drought and the precipitation anomalies impact those. We had a tough time trying to use those because we were looking at point data only in the mountains in certain areas. So we're trying to look at more base information that's going to drive ERC. So if you look at the ERC values like right now, you should see them reflecting the current weather pattern, the recent rain, and so forth. So not exactly ERC, but the things which drive that.
Thank you.
And maybe this is a good time to mention that if you're curious about some of the methodology behind the Predictive Services work, they do have a nice video that describes what factors and how those factors are used to build up their estimates.
Thank you. Thank you for remembering that. Yeah, the intent someday was to have some kind of constant monitoring site or resource where you could look at those kind of 5 factors all the time as they progressed throughout the year. So we're hoping to move to something like that where anybody can kind of self-evaluate as we go along, and then we'll do our kind of expert assessment on a periodic basis.
Hey, Chuck, this is Tobin Smale.
Hi there.
Say, Charlie was unable to make the call, but I just want to make a quick plug for the land fire product that we're working on for NDVI that hopefully we'll be able to get to you guys to help with your fine fuel predictions starting here for 2015. So just be on the lookout for that to add to your predictive services, hopefully.
Thank you. Yeah, that would be a critical part of our monitoring. Thank you very much. Yeah, we've been working with those guys to try and come up with a process to evaluate the current fine fuels and to kind of predict it ahead, using predictive information. So, heck, if we can figure out that kind of stuff, we're in good shape.
So, up to what, 3 weeks or a week or a month or what?
I think we were looking at. Oh, you mean? I'm sorry. When's the stuff going to be available?
No, like you would get like a satellite image that would, and then theoretically use that to predict fuels.
Yeah, I think so. I think they had a base image, and then they were going to look at the environmental conditions, including things like precipitation. And I'm not sure if they were just integrating the precipitation in with a scan, but trying to find a way basically to refresh the fine fuels for every season, so that from remote sensing year to year what's actually out there, just not the base fuel model map. So hopefully and I'm not sure, maybe we could maybe we could do a whole separate webinar on that one.
Yeah.
Yeah. I mean, and you're pretty close on that one. And it's mostly NDVI that we're looking at with Landsat 8, but we're collecting kind of the preseason data, watching green up, things like that, and then correlating that to fine fuel cover.
So if you give that to a manager, you're telling them that's your fuel conditions as of the last 2 weeks?
More of a preseason type green up. So we would be collecting data for 3 months to try to determine where that fine fuel is greening up at the locations. And then we correlate that to a cover up to, say, May is what we're looking at now. And so that would give you kind of a quick capture of what that fine fuel is looking like. Does that make sense?
Yeah, it's tough because I think we're trying to look at both the herbaceous state and the loading components together, which makes it complicated.
Absolutely. But it's something new that will be coming out, and hopefully we can all take a look at, and Chuck can add to some of that.
So stay tuned on that one.
Yeah, because I know that the Coronado had always kind of been saying that there were some areas in the lower elevations in the oak woodlands that they wanted to burn, but it was hard for them to kind of know those perfect conditions, and they thought it was a short window, and it was hard for them to kind of get a hold of when that window was. So I think something like that might be pretty helpful now.
You're right. It's hard for us too.
Yeah. So based on your predictions of the monsoon, it seems like last year it seemed like we had a lot of these managed fires, or whatever we want to call them, lightning ignited fires, and it was because the monsoon kind of kept, went for a while. So do you see that monsoon kind of staying around for a while, or it seems like your predictions are for it to be kind of spotty at times?
Well, I think if it's going to be spotty, it's going to be probably across the eastern half of the area. That's that's the signal we're seeing now. So areas from the divide east may see issues with it becoming more spotty. The western half of the area actually looks pretty decent.
Oh, okay.
And again, this is just kind of behind the scenes we're looking at. We're not sure we want to show it to anybody, so
yeah.
It's kind of scary. Plus, they're already starting to talk about the big El Nino coming up, so watch for that one.
This is the same El Nino that we've been hearing might come for a couple of years.
Yeah, I know. Exactly. Now it's really coming. It's really
Yeah, it's sort of, yeah.
I'm not so sure what to say about that one.
Yeah. Any other questions out there or comments? Well, Chuck, I want to thank you again for joining us, and I appreciate everybody for participating, and please do stay in touch. We'll be setting up registration for the next webinar, which I believe will be a mixed conifer panel discussion. And as we close out this webinar, you will be directed to a quick survey, and if you could just take maybe, I think it's about a minute and a half to fill that out, we'd really appreciate it. It helps just give us some ideas about where we can improve. So with that, thank you very much, and I look forward to at least connecting via webinar, if not in person, with all of you soon.
All right. See you guys.
Thank you all.